Lecture 1, Part 2. What are we going to do in this first lecture? Well, we're going to talk about databases, give you a little picture of databases, what they look like. And so, and you learn some words. You always have to learn words in your any new thing. And so the basic thing of databases is this things called tables. And they look just like you've seen in a spreadsheet, is rows and columns. Columns go up and down, rows like this. You'll notice that the columns all look about the same. Got the first name, they're all first names. The last names, they're all last names. Address, street address, they're all street addresses. City and state, they're all those things as well. So that gives you an idea of what a column is. A column is a group of things that are all the same. Fields, also known as a single item in a column, which is the confluence of a row and a column, is called a cell. One little data item, or and one line, one row is also known as a record, because a record is a whole bunch of data associated with one thing. So, not line 61, record 61 is Melissa Chante from 3201 Glenwood Avenue, Raleigh, North Carolina. That's one person in the database, one thing. And tables are all, you don't put people and dogs in the same table. You have a separate table for each type of thing. Why is that? Because you're not going to have a field called hair color or fur length in fur length or fur color in a people table. So you want the people data to be all about people and the dog data to be all about dogs. And so we separate them out. So you end up with multiple tables in your database. You're going to have a database for people. Almost every database has a table for people. Well, every person-oriented database anyways. But, in health, you're going to have a table for blood readings or appointments or so many things, so many different types of tables, and each table is separate. So that's what makes a database special from an Excel spreadsheet. Because an Excel spreadsheet, you only got one, pretty much you got one table, one row and one column. So you have to do all kinds of things to shoehorn different types of data in there. And whereas a database, you can be much more principled. You can say this thing is about this type of thing, and you have it's put in a table. Fields, records, table, cells. That's what I want you to walk away from this slide with. Tables are lists of things, people, episodes. The data is all the same type of thing. There's no redundancy. So if your person name is in one place, you don't have it somewhere else. You don't store it in two different places. That's the cardinal rule of databases. Only have the data in one place, mostly, except for the exceptions. But and a record is a individual entry. A field is a certain column, and a value is a thing in the cell, the thing in an actual cell. Yeah, so that's the components of a database table, and we're going to build up from there. So a database, the base thing in a database is tables, where they have a structure and they have data in them, and that's another thing that databases do better than Excel spreadsheets, is they have a structure. You can say this column is for this type of thing, and you can have an error if you try to put some garbage in there. You try to put some garbage in an Excel spreadsheet, Excel just says, I love garbage, and just eats it up and just causes the problems for somebody else down the road. So databases are better for structuring your data and making it clean and not screwing it up. But more, the relational database has not just tables. It has multiple tables, and each one holds a distinct type of data, and it stores them all together so that you can use them together. Oftentimes you want to use things together. There's definitions and rules, as I was talking about before. Each column is defined. You can say, I won't let you put this data in this database. You cannot call someone 1234. That's not a proper name. Names have to be alphabetic. You can say things like that. You can say You can't add someone who is over 200 years old or negative 10 years old. You can put rules in your database to make it so that it's principled, and you can't put garbage into your database. And then, because the data is stored in multiple tables, you need to be able to join them together afterwards. You've got to be able to say, oh, well, this is the person's episode. This is the person's appointment. You need some way of joining them together. So there's also linkages between tables. We've also called relationships. And how you do it is you have these things called primary and foreign keys. So a primary key is the flag, the thing that you associate with a certain record. So if we go back to this slide, the ID is the primary key. There is only 152 in the world, and that is Denver. There is only 153 in the world, and that is John Emery. In this customer 53, I guess we could. And so if you were in another table, for example, the appointments table, and you wanted to say, this is John's appointment, you wouldn't put John's name in the appointment table. You'd put 53, because that's good enough. You can go look up John if you need to find out where they live or their phone number or what their last name is. You can go look it up. Also, if John wants to change his name, he gets married, he changes his last name, then you just have to change it in one place. You don't have to change it in the appointment and in the database table. You change it in one place. So that's a reason why we have foreign keys and primary keys. The primary key keeps track of John and gives us a handle by which we can hold on to him. And then the foreign key is the thing that we use to point back to this record. The foreign key in the appointments table, in the episodes table, in all the places that need to point to this table is called a foreign key. We'll show you that in a bit later. I was going to stop somewhere, and I'm not sure if this is it. Yeah, so databases have evolved over the years. And first they were just like a single data file, basically like an Excel spreadsheet, one particular data file. But we wanted to be able to do linkage. We wanted to be able to do things. So we ended up we had to link things together using this idea of relational databases. And then once we've got the relational databases, we want to be able to define the data to say, well, this column is just for numbers, this column is just for text. We want to have rules. We can also incorporate that into the database. And then finally, because we've got all this other stuff in the database, we want to be able to generate reports and generate forms for entering the data, and even generate software for doing tasks on the data, defined tasks. At 10 o'clock every night, we've got to go and clean out the data set and move all the data from this one table to this other table. Programs that do stuff with the data, and all that is within the database. Just to let you know that Access Microsoft Access is this software that comes from a lineage of data.